Number one, the following question examines the change in darts players' scores using two statistical tests. In the sport of darts, players take turns throwing darts at a board in order to score points. This is the darts. A player's three-dart average refers to the mean score achieved when throwing three darts. Valia aimed to find out whether amateur dart players in her local area improved over a 12-month period. An increase in their three-dart average will indicate an improvement. She selected a random sample of 8 darts players and recorded their mean three-dart average from year 1. She then recorded their mean three-dart average from year 2. Valia's results were as follows. On this table, the data. Valia calculated the median quartiles and interquartile range for each year. The results are shown in table 2. A, B, C. Median A, upper quartile B, interquartile range C. Determine the values of A, B, and C. So we are going to, the first step, we are going to arrange this data in order for year 2. So year 2. From the smallest number to the greater. From the smallest to the greatest. Right. The smallest is 65.0, 68.0, 68.0. You can compare with data on the table, 70.1, 70.6, 72.0, 74.9, 92.9. And we're going to determine A. A is median according to the information in table 2. And median, there are 1, 2, 3, 4, 5, 6, 7, 8. It means median between here, 1, 2, 3, 4, 1, 2, 3, 4, here, the median. Median or as the quartile 2. Okay. This is 71 plus 70.6 divided by 2, and it is 70.35. And after that, B, according to the table 2, that this is upper quartile. Upper quartile, it means this data. So we're going to find the median of this data 1, 2, 3, 4. Is here. This is the upper quartile. So 72.0 plus 74.9 divided by 2, it is 73.45. And next C, according to the table 2, this is interquartile range. Interquartile Interquartile range is upper quartile minus a lower quartile. So we're going to find the lower quartile. Upper quartile, this one, 73.45. So we need to determine first the lower quartile between this number 1, 2, 3, 4. So here, the lower quartile, 68 plus 68 divided by 2, 68, and 0. And the result is 5.45. So question B. By comparing the results for both years summarized in Table 2, state one conclusion in context that Valium might be justified in making. Okay, so my opinion be some players. I'm going to writing here. Some players are showing improvement over the 12 month period as indicated by the increase by the increase in both median and upper quartile scores. Question C. Falia then decided to analyze the data from Table 1 using a one-tailed pair t-test at the alpha or significance level 10%. 10% it means 0. Alpha 0.1. Okay. To determine whether the player's averages have increased. State an assumption about the differences in means that is necessary in order for the test to be valid. So C, the individual meaning change in mean are independent one another. It means there is no correspond. Yeah. D, state the null and alternative hypothesis for the test. Find the p-value, state the conclusions of the test in context, justifying your answer. Part D. Okay, the null hypothesis and the alternative hypothesis. The null hypothesis is mu d equals 0, and the alternative hypothesis is mu d greater than 0. Mu d is representative, the mean of difference from differences from the first table. You can evaluate the first table, the table 1. Okay. Second, I mean the second step. This is part 1. This is the first step. Okay, and the second step, we're going to find p-value. To find the p-value, first we need to find the difference on this table. This table. The table 1. Okay, difference. So the difference is this one. Justin, the difference 70.1 minus 68.1 is 2, 2.0, and this one is minus 0.2. This one minus 0.8, and this one 1.6. Minus 1.8, and this one is 3.5, 1.4, and this one is 28.0. That one. And after that, I'm gonna find the next column, the I minus difference mean. Okay. Okay. And then difference mean is just now we already determined the mean with the mean not yet. I'm gonna find the mean first. Mean is mean of D. Sorry, but mean of D is, and this number plus this number plus this number and plus 28. It is 33.7. So mean of D, mean of D, mean of D, or one. If you divide by 8, this number is 4.2125. This is, so after that, these numbers, 68.1 minus, sorry, yeah, minus 2 minus 4.2125. Okay, and we got the result minus 2.2125. After that, minus 0.2 minus 4.2125. We got the result minus 4.4125. And then continue with the same method, 125. And this is minus 2.6125. And this one minus 6.0125 minus 0.7125 and minus 2.8125 and 23 minus 7875. So 28.0 minus 4.2125. Okay, the result is 123.7875. And after that, the I minus mean of D squared. So this number squared is 4.8945. After that, 19.4531. 25. 1203. 6.8 258. This one 36.0756. 0.5089. This one 7.9023. And this one 566.6189. And if you calculate all this number, the result is 667.3984. This number. Next. So after that, we're going to determine the standard deviation. So the mean is 4.2125 and standard deviation, D standard deviation, wait, standard deviations of D or S, D, this one, square root 667.3984 divided by 8 minus 1. It is 9.77. One. And the next step, the T statistic. The statistic is the formula T equal mean of D divided standard deviation divided by square root N. N is 8. This is 4.2125 divided 9.77 divided by square root 8. So 4.2125 divided, this number I have calculated. The result is 1.22. So, and if degree of freedom, the F, 8 minus 1 equals 7. So the p-value based on this information you can determine through calculator or through table. The p-value is 0.3133797 in calculator. In table 0.3134 or 33. Yeah, that is the p-value. And next, please state the conclusions of the test in context, justifying your answer. Part 3. So p-value 0.3134 or 33 is greater than alpha. Alpha is 0.01. So it means we fail. The decision is we fail to reject. The null hypothesis. And conclusion, the conclusion there is no insufficient evidence at the alpha equals 0.01. Okay. Uh, 10%, it means not 0.01, 0.1, sorry. What is 0.1? 10% is 0.1. Yeah, 10%. Alpha, 10%. And next for the conclusion, uh, to conclude that the players have increased from year 1 to year 2. Well, next question. Okay. Well, Falia was not sure the assumption made in part C was correct, and hence, though the result obtained from her paired t-test may not be valid. Following further research, Falia decided to use the Wilcoxon sign rank test, which does not require the assumptions she made in part C. For this test, the magnitudes of the differences between the year 2 and year 1 means are ranked from 1 to 8, with the ranks from the positive differences P, so P is the positive differences in this column, this table, and the ranks of the negative differences is N, separated in this column, this table. This partially is shown in the following table, which Valia constructs to perform the test. This and the question, determine the values of A, B, C, and D, and sigma n. For this test, the Wilcoxon sign rank test statistic is T. T is the smaller value from a choice of sigma P or sigma n. For the next series for G. Now, we are going to find first T is F, A, B, C, D, and sigma n. So if we create the rank, we need to add one more column for the absolute difference. This one. So absolute difference of 2.0 is 2.0, and for minus becomes positive. So it becomes positive, becomes positive, becomes positive, becomes positive. Still 1.4 and 28. I'm going to fix this one first. Okay. Now we are going to rank this the absolute difference. The smallest number is this one. This is so what? According to this information, this is the second. And the third is this one. Okay. And after that, the fourth, 1.4. The fifth is 1.85. And the sixth is 2.0, 6. The seventh, 3.5, and the highest is 8, 28. So according to the information that A equal 6, then B 5, C 7, and D equal 4. Writing here A A A equals 6, B is 5, C is 7, and D is 4. Sigma n, let me look, evaluate the table. Table n is 1 plus 2 plus b equal 5. It means 1 plus 2 plus 5. So sigma n equal 1 plus 2 plus 5. It is 8. Next, G. So the test the Wilcoxon sign rank test statistic is T equal the smaller the value from a choice of sigma P or sigma N. P is positive, N is negative. The null hypothesis is that the population's median for 3-dot average is the same in the both years. So the keyword is this one, the same. This is the null hypothesis. The population is median, the population's median for 3-dot average is the same in both years, in year 1 and year 2. Valia chooses to carry out the test at the 5% level of significance, alpha 5%. From the statistical tables, she determines that the critical region is t less than or equal 5. State the alternative hypothesis for this test. Alternative hypothesis is I'm gonna copy this one. This no hypothesis, the populations, medians. Okay, the populations median. I forgot, for 3 that average for 3 that average uh, is greater or is increased. I'm gonna using the term increase. Okay, in increase from year 1 to year 2, or for both. From year 1 to year 2. From year 1 to year 2. That is the alternative hypothesis, or we can state like this: alternative hypothesis is mu d greater than 0. It means the population's median difference between year 1 and year 2 is greater than 0. And that's this one. Second, write down the value of the test statistic T. Determine the conclusion for the text in context. The statistic, the value of t, that is statistic, the value of t, we already calculate this is 8. And the third, the critical region, the critical region for the test at alpha or significance level 5% or 0.05 is t greater than 5 or if t equal 8 or 8 greater than 5. This one. Or t equal 8 greater than 5. This one. H. Suggest briefly how Valia could assess the reliability of her results for either test. Okay, this is my suggestion. The Valia could repeat Valia could repeat this test, the same test for the next year. Okay. Or the second opinion you can state this one, or the second, Valia would repeat the test with different sample for this year. So if Valia would like to repeat this test with the same sample, she has to repeat the test uh, on this year, but different sample. If Valia will repeat the test with the different sample, she can repeat the test. She can do the test on the next year. Okay, that's if the same sample doing the test on the next year. If different sample, she can do the test on this year. So that's the difference. For the next year, uh, with the same sample, better if I'm writing here, same sample, same sample, and if this year she has to find a different sample.